Yeah, so we're looking at exploring the capabilities that directed energy has to offer against counter UAS, counter unmanned aircraft system threats, small man-portable systems. The Air Force has three major areas: air-based defense, precision engagement, and aircraft self-protect. This is the first probably near-term low-hanging fruit that we can actually get after as we start opening up the bottleneck for directed energy, transitioning it from the S&T side of the house to operationalizing it. So right now, we need to be able to provide our warfighters the capability that they may not necessarily have or they may be challenged with. And so the directed energy offers a new set of capabilities to be able to do that in either a more timely or more effective fashion. Yeah, so this is moving past a tech demonstration to prove out technical feasibility. This is really looking at exploring the doctrine, the policy, the training necessary when we go out and take these systems into field. Do we have the right concepts of operation, the tactics, techniques, and procedures in place to actually use these systems? Yeah, so we have a high power microwave system and a high energy laser system. Both came out. We looked at and are exploring the capabilities that both have to offer independently, as well as a joint look in engagement. So the systems themselves, when we explored doing this experiment, they had to be able to have their own battle management C2 radar EOIR capability. So they are able to operate independently if necessary. They also have the hooks to be able to integrate with the existing overseas defense structure. So the command that we use overseas, they have the capability to actually link into that. Yeah, so first off, when you're going to be employing directed energy, it's probably going to be a synergistic look at both DE and kinetic options in the employment. Directed energy offers some unique capabilities of low cost and quick engagement, time of flight. You're looking at time on target immediately based off of photon engagement. Yeah, so I mean, the use of these systems has not been proven out in an operational sense. So I think that's really the unknowns that we're trying to explore, and really looking at capabilities that these have to offer extends our range, as well as provides unique capabilities against complex threats that we don't necessarily have in terms of a cost-effective approach. So I mean, you're looking at, when tapped into a land energy source, cents on a shot. Versus, thousands of dollars that may be used in a kinetic munition to be able to take down a threat. Per shot, yes. Now the DE systems themselves are a little bit more expensive, so there's a cost trade-off on investment for a long-term employment. So your laser engagement is really going to be a thermal energy disposition on the target. So you require the energy to heat up on that target to be able to destroy it. The HPM system gets in through different mechanisms to actually affect the electronics that are flying that system. I think it depends on the kinetics and how effective you actually need to be. For right now, what we're looking at for this experiment is purely on the DE side. We'll do some post-analysis on how it actually compares to the kinetic after this event. In terms of directed energy for the Air Force, there's a lot of activities that need to occur throughout the Air Force organizations in terms of life cycle management, sustainment. Those are all being captured here when we start to look at transitioning these systems overseas. Right, so we are working with our service partners in terms of exploring these capabilities, and then yeah, I'm from SDP, and it's a small organization. We have like 30 or so people. In reality, we're tapping 150 people from different Air Force organizations to be able to actually leverage the capabilities that we're exploring in the experiment that we have right now. White sands provides us a unique flexibility for the space that's involved, and then we also have a significant history on directed energy use out in this space. So we've been very happy with being able to explore the capabilities that are offered here.
the Strategic Development Planning Experimentation. We're really excited about being out here at the WSMR and actually trying out directed energy, which directed energy consists of both high-powered microwave and lasers. And the WSMR range is just a phenomenal setup and a location that we want to continue to use just because of the proximity of the equipment that you've got and the capabilities that it brings to directed energy experimentation. We are looking at the abilities to kind of go after unmanned aerial systems, and it's to hit it with both lasers and high-powered microwave and seeing the effects of both those. So you heard the laser comment. Most of the time we actually hit that and it actually burns a hole, a kinetic effect where it actually drops it out of the sky because of that burned hole. With high-powered microwave, it may be a little different. It may just interrupt the actual performance and the weapon system will have to go back to where it came from. It may actually do enough damage that it loses its control, so like an autopilot, and it loses that autopilot and it drops to the ground. And so we're looking at that capability, and it's kind of a non-kinetic effect, and it's unique that we don't always understand non-kinetic effects. Will it do enough damage to drop it out of the sky, or will it return to base? Yeah, so experiments, so if you're looking at technology maturation, this is about what we call a 6 on a scale of 1 to 10. And so it is getting to the point where we have it integrated, but there's some other aspects that we got to understand before we deploy it. So coming back from Afghanistan last year in October, I was at a base where we had a lot of unmanned systems sitting over and watching everything we do. And so for the future, our airmen would like to not be monitored 24/7. And this will push that back so they don't have that monitoring capability. Yeah, so UASs are being populated everywhere, and we're seeing them all the way from the commercial side to the military application. We've got to understand what they're doing, and we actually got to prevent them from gathering knowledge that they shouldn't have. If you look out, White Sands has got a lot of open space, and we want to make sure we understand the capabilities of directed energy before we actually put it in an urban environment. And this is just an ideal location to do that. It's got a lot of sensing capability. It's got a lot of radar coverage, so we know when stuff goes up and we can capture that, understand it, bring it back to the research scientists so we can actually look at it from a modeling, simulation, and analysis perspective that we don't have to do numerous tests. We can actually do that with modeling, simulation, analysis. Yeah, I think the important part of experimentation, you hear a valley of death, where we have technologies in the lab, we don't always get it out to operating units. This experimentation bridges that valley of death, gets it out to the operators earlier on so they can experiment with it and understand it before it's actually deployed.